welcome back, everybody. Last week we talked a little bit about, the project setup and how we're going to kind of bring this all together. Today, in the little bit of time we have, what I would like to do is actually walk through some of the hardware setup and config to get us started with getting essentially the base of the sensor itself operational. And then we can then start to expand that into other areas and how we can tie that communication together. As Aaron said, there's always some housekeeping pieces that we like to cover. Confidentiality and disclaimer pieces, those are the typical things, which is if I happen to mention anything forward-looking, pretty much just disregard that because of the uncertain times we're in. We don't know with regards to everything going on, but I don't think we're talking about too much future-looking stuff in today's discussion. As a kind of a reference, I'm Bill McLane, and I am the messaging evangelist at TIBCO. I've been with TIBCO for about 20 years, and I'm trying to figure out what message evangelist actually means. I've had that role for about 2 years now. But what it really kind of boils down to is that, I just have a passion for communications, both at the computer science and software level, but also in the human interaction level. And so I bring those two things together to kind of spread the word about what TIBCO can do for high performance, low latency, enterprise level, IoT level communications, and how we can tie that together. So like I said, last week we went kind of through the hardware piece of things. This week what we want to do is really start the process of building out the sensor itself so that we can start to gather data and leverage that data and expand that into other areas. So to kind of start the framework for how we're going to build this out, we talked a little bit last week about how the hardware we're going to be building this on is a Raspberry Pi. What I'm using here is actually just a Raspberry Pi 3 that I had available lying around. I updated that to run the latest Raspberry Pi OS. It used to be called Raspbian. I'm using the desktop version that was released in May of 2020. And you can actually find that on the raspberrypi.org downloads page, which is linked here. So you can go ahead and grab that. And then I installed that onto an SD card, a micro SD card to basically deploy that onto the Raspberry Pi. I don't think we'll go into the details on how to do that for every individual person, because how you install and basically burn the image onto an SD card is pretty variable depending on your OS and things like that. But there are instructions that are listed as part of the raspberrypi.org site that you can follow that are pretty straightforward and work very well to getting that image burned onto an SD card for operating your Raspberry Pi OS. The other layer that we really need to talk about here is the aspect of getting the sensor hooked up. So, as is typical for a lot of these kind of hardware projects, there's a little bit more nuance to building out sensors and tying them into different components. This is pretty much a pretty easy one from the experience I've had. There is some just caveats that you have to look at with regards to how you're wiring things up. But what we're going to do to wire up our sensor is really we need 4 wires that are going to come off of the GPIO portions of the Raspberry Pi board, and those are going to tie directly into the HCSR04 sensor that we're going to tie those in. That goes through 4 wires, like I said. The sensor VCC wire, which is going to basically be plugged into pin number 4 on a Raspberry Pi 3, is going to connect to the DC power of 5 volt. The sensor trigger wire, which is green in our diagram, is going to plug into GPIO 17, which is actually pin number 11 on your Raspberry Pi 3 GPIO board. That's a straight line as well. And then we have 2 wires that we need to do a little bit of work on to get them operational, specifically the sensor echo wire, which is going to plug into GPIO 27. And we're going to have to provide 2 resistors to basically do some voltage flow with those wires. The first resistor that we're going to put in is a 470R ohm resistor, and that's going to be directly in line with the the echo wire. So you can actually see this on the diagram. It's the top resistor. It basically just runs in between one wire that's connecting to the echo and through to the sensor itself. And then the other resistor that we have to add is a 1K ohm resistor that's going to ultimately bridge our echo wire to our ground wire. And our ground wire is going to be plugged into pin number 6, which is directly below the voltage 5 line. And again, that resistor, that 1K ohm resistor, is going to connect on one side to the ground wire and on the other side to the echo wire. Once we do that, that gives us the operational sensor, and we'll bring that in so that it will power that sensor, and we can get feedback on that sensor into the Raspberry Pi setup. So to get the project going, we really just have to do a couple of things. Once we boot up our Raspberry Pi, we're going to configure the region, configure your Wi-Fi if you're connecting via Wi-Fi, which is what I'm going to do here, making it easy for me to send and receive data down into where my sump pump is. And then ultimately, we're going to update the whole system using the Raspberry Pi config options that are available. You're going to do that as root, so an sudo. And you can update the whole operating system and all of the tools that are available on it as well. Another thing you might want to do is expand your file system as well. That's usually found under the advanced options. You can expand your file system to leverage the full SD card setup, but this project typically doesn't use too much data, so you don't necessarily need to do that right away. For the actual sensor data, what we're going to do is install a number of components. Specifically, we're going to install Matplotlib and NUMI. So these are for charting and putting that data into charts. And then we're going to install a couple of things. We're going to install pip and Python 3, make sure that those are all installed. And then we're going to actually install a project called Raspberry Pi Sump. And that is the second to last command that we have there with pip3 install of Raspberry Pi Sump. And then we're going to make sure that that's up to date. So once we do that, now we are actually ready to start operating and using the sump pump sensor and the HC sensor to detect different levels with regards to volumes of water within a sump pump tank. There's a couple of configuration options. Everything in this project is actually installed in this particular case into /home pi raspberry -sump. And I'll show you that here in a minute. But the configuration options out of the box will work for you. So the trigger pin and the echo pin are configured to the setup that we configured the hardware in. And there's a number of things that you can set with regards to the pit depth and the metric. So you can set the metric, the units to either metric or imperial. You can set the critical water levels. You can set the pit depth. You can set a reading level if you're going to be reading this on a higher frequency than a minute. And then you can set temperature for where this is at, as well as if you want to alert when water levels are high or low, because one of the things you could actually use this sensor for is not necessarily for sump pump management where water levels are going high, but you could use it for fountain control and things like that where water levels want to be maintained at a specific level. There's a number of other options that are available to you, specifically on charting colors as well as email notification. I'm not going to set those up at this point. But so with that, once we have all of that ready to go, we can actually take a look at this in action. And so let me just go ahead and let me see about sharing my other screen here. And we can, I'll stop this for a second. And if you take a quick look, one of the things that you can see here is that we have on my Raspberry Pi, you'll see that basically if I go in and take a look, there is going to be a directory that was installed here called Raspberry Pi Sump. There's a number of different things here with the configuration and documentation in here. But one of the areas that we have here is that we have a CSV folder where I'm actually tailing the water level CSV that we have output for today. And if I run sump.py, what you'll see is that in that it will actually go off and take a reading, and that reading is giving you the depth of the water. This is artificially created right now. My Raspberry Pi is sitting over in the corner, and I've got some things that are actually measuring depth and things like that. But if you notice, every time I run this Raspberry sump.py command, you'll be able to get a water level reading with a timestamp in it. So what we're going to do going forward and going in our next kind of phase here is going to be is we're going to actually take and leverage this data, and we're going to start to extend it to other pieces. So specifically what we're going to do next week is we're going to go in and extend our sensor readings and be able to take that data and read that data off of the sensor itself, and now be able to publish that data for consumption into an MQTT system.